You've learned how games create realistic environments through careful technical choices. Now we're going to explore one of the most breathtaking environmental systems in modern gaming, how Ghost of Tsushima makes an entire island feel alive through its grass and wind rendering. The first time you crest a hill in Ghost of Tsushima and watch the guiding wind pull through the pampas fields, something makes you stop. You don't rush to your next objective, you just watch. The grass waves like water, leaves spin like dancers in the air, and cherry blossoms drift across battlefields with weight and purpose. It doesn't look like a video game background, it looks like a living painting that breathes with you. What you're witnessing is one of gaming's most impressive technical achievements, a world where every blade of grass has actual presence, and where an invisible tide of wind coordinates the motion of everything. The island of Tsushima doesn't just sit there waiting for you, it performs. To understand what makes Ghost of Tsushima special, you need to know how most open world games handle grass and foliage. In games like Horizon Forbidden West or Red Dead Redemption 2, grass fields are created using flat textures with transparency. Imagine cardboard cutouts of grass clusters standing upright. These are called billboard sprites or alpha cards, and they're cheap to render because they're just flat images that always face your camera. But here's the limitation. Flat images can only bend or sway in simple pre-animated patterns. They can't catch light from different angles realistically or respond individually to wind direction. They just play the same looping animation regardless of what's happening around them. Ghost of Tsushima took a radically different approach. Every grass blade you see is actual 3D geometry, a real mesh with volume, edges, and surfaces that catch light. Not a picture of grass, actual modeled blades. Here's the challenge Sucker Punch faced. If every grass blade is a full 3D mesh, and a single field contains over a million blades, how does the game render that without the PlayStation 4 catching fire? Normally, for each object you want to render, every tree, rock, or enemy, the CPU sends a draw call to the GPU saying, here's an object, here's where it is, now render it. If you have a million grass blades and send a million individual draw calls, the CPU spends all its time just issuing instructions instead of running the game. This is where GPU instancing saves the day. GPU instancing lets the game render thousands or millions of identical objects using a single draw call. Instead of telling the GPU to render each grass blade individually a million times, the game says once, here's one grass blade mesh, and here's a list of a million different positions, rotations, and wind parameters. Render this blade a million times with these variations. The GPU receives one base mesh, the shape of a single grass blade, and one massive list with position, rotation, scale, and wind behavior for each of the million instances. Then the GPU clones that base mesh a million times in parallel, applying the unique transformation data to each copy, all in a single instruction batch. This is why Ghost of Tsushima can fill the screen with individually moving grass blades without performance collapse. The CPU isn't overwhelmed issuing instructions, and the GPU handles the geometric replication efficiently because modern graphics cards are built for exactly this kind of parallel processing. You might wonder, if a million grass blades all share the same base mesh, wouldn't they look identical and repetitive? That's where the shader does the heavy lifting. While the blades share geometry, the vertex shader, a program that runs on the GPU for every blade, procedurally modifies each one in real time based on its unique parameters. Each blade samples the wind field at its specific world position, so nearby blades sway together but distant patches move differently. Each blade also has a random stiffness value. Some bend more easily, others resist harder, plus height variations and subtle color tinting to prevent uniform green repetition. The result? Even though they are technically the same mesh, every blade behaves and appears unique, calculated by the GPU every frame. Here's what elevates Ghost of Tsushima from impressive grass to living world. The wind isn't just a grass effect, it's a single global simulation that drives every reactive system in the game. The wind exists as a low resolution vector field, a grid spanning the entire game world where each cell stores wind direction and intensity. Think of it like a weather map showing wind flow across an island, but updated every frame. Every moving system in the game reads from this same wind field. Grass blades bend along the wind direction. Trees and bamboo follow wind intensity. Cloth and capes add wind force to their physics. And particles like leaves and cherry blossoms drift with wind velocity. Even smoke trails curl and distort based on local wind turbulence. And the guiding wind mechanic, the one that shows you which direction to travel, is part of the system too. When you swipe the touchpad, the game spawns a localized gust along a path pointing toward your objective. That gust modifies the vector field temporarily, and every reactive element responds. Grass leans, leaves swirl, banners ripple, all because they are sampling the same unified data. This architectural decision, one wind simulation powering all systems, creates something most games can't achieve: coherent environmental performance. When a storm rolls in, the grass doesn't just sway faster while the trees stay still. Everything accelerates together. When you summon the guiding wind, the entire landscape leans in the direction you need to travel, creating this sensation that nature itself is guiding you. Players don't consciously think about the technical systems. They just feel that the world responds, listens, and breathes with them. That emotional connection, the reason players pause on hilltops just to watch, is the payoff of Sucker Punch's technical choices. The grass isn't just decoration, it's part of a living system where wind, light, and motion coordinate to create presence. Ghost of Yotai, announced for PlayStation 5 in 2024, takes this foundation into harsher, colder territory. The trailer shows snow replacing grass and pine forest bending under northern winds, the same living world philosophy refracted through winter. Being PS5 exclusive means Sucker Punch can push the system further with denser geometry, expanded instancing, advanced lighting, and faster streaming. The complete technical improvements are detailed in the explanation, but the core principles remain: unified wind simulation, GPU instancing for massive scale, and environmental systems that coordinate through shared data. The hardware upgrade lets them apply these techniques to even more complex biomes: alpine forests, volcanic ash fields, icy mountain ridges, without compromising the breathing, responsive world that defined Tsushima. You now understand how Ghost of Tsushima renders millions of grass blades using GPU instancing and coordinates all environmental motion through a unified wind system, creating the illusion that nature itself is alive. Next, we'll explore how other technical decisions, like procedural animation and dynamic weather transitions, layer onto this foundation to complete the experience.